All right, let's unpack this. Imagine for a moment that iconic periodic table of elements, the one that probably hung in your high school science classroom, all those neat rows and columns, the letters, the numbers, organizing everything we think we know about matter. Now hold that image in your mind and consider this. What if everything we thought we knew about that table, about matter itself, was built on, well, an incomplete picture? What if it was just the surface of something far deeper, far more fundamentally ordered? Welcome to the deep dive. Today, we're going to plunge into a truly revolutionary framework. It radically redefines how we understand atoms, elements, and maybe even the very fabric of life and the universe itself. We'll be exploring a groundbreaking paper titled Nuclear Alchemy, and it's far more than just a new classification system. It proposes a periodic table of elemental genesis, revealing what the authors describe as a single resonant code embedded in the vacuum coherence field.
Yeah, imagine the universe not as like a random jumble of particles, but as if it's built on a hidden rhythmic blueprint.
Like a subtle, vibrating lattice woven into the very fabric of empty space itself. Sounds pretty wild, right? This deep dive will challenge us to think beyond the familiar electrons and atomic numbers. We're going to explore some pretty mind-bending ideas like coherence geometry, recursive tetrahedral substructures, and even a new, rigorously scientific take on alchemy. You'll hear how this audacious framework links everything from the mysterious formation of nanodiamonds around distant stars to the very architecture of human consciousness. So get ready to ask some profound questions. Why do elements have their specific stable forms? Why does life on Earth so consistently favor certain isotopes? And what if matter isn't just randomly assembled, but actually emerges from some kind of fundamental cosmic rhythm?
What's truly fascinating here, I think, is this shift in perspective. We're moving from merely observing and classifying phenomena to understanding their origin, their genesis. The traditional periodic table, the one we all learned, it's been an indispensable tool for, over a century and a half? Mendeleev's empirical arrangement, later beautifully refined by quantum mechanics. It allowed us to sort elements by atomic number, electron shells, chemical properties. And while that model is undeniably powerful, it's great for predicting chemical reactions and understanding atomic behavior, it never fully answered the fundamental why.
Right.
It didn't explain why elements exist as they do, or why a nucleus with, say, this many protons and neutrons would be stable, while another, very similar one, would be highly unstable. And crucially, it didn't explain why life itself seems to actively select for and prefer specific isotopes. It's been an excellent map, sure, but maybe not the true blueprint of creation.
That's a perfect analogy. Yeah, it's like having an incredibly detailed map of a city showing every building, every street, but zero insight into how those buildings were actually constructed, or why they're positioned the way they are, or why certain materials were chosen. This new paradigm, then, as proposed in nuclear alchemy, offers that blueprint. It's a fundamental shift from simply classifying elements to truly understanding their genesis. Our focus moves from just particles to form-generating coherence. That's a whole new way of thinking.
Precisely. This work introduces a resonance-based periodic table, one that's fundamentally founded on the geometry of nuclear coherence. At its very heart is what they call the Tetrahedral Nuclear Genesis Principle, or TNGP. And this principle asserts a truly radical idea that all stable nuclei are not just random agglomerations of protons and neutrons. No, they're actually built from recursive tetrahedral substructures. And what's even more compelling is the assertion that these substructures resonate directly with this underlying vacuum coherence field we just mentioned. So rather than elements arising from like a chaotic accumulation of nucleons, they emerge from a highly ordered symmetrical alignment with this pervasive field.
Okay, so let's really unpack this core concept, the TNGP. It claims stable nuclei are built from recursive tetrahedral substructures. Can you break down what that means? Like, how should we envision the fundamental building blocks of matter now?
It's quite specific, actually, and pretty visually intuitive once you grasp it. They define a tetrahedral unit, let's call it T, as a coherent cluster of exactly 4 nucleons that's 2 protons and 2 neutrons.
2 and 2. Got it.
Right. Imagine these 4 particles arranged precisely at the vertices of a perfect 3-sided pyramid, a tetrahedron. This cluster, they argue, forms a geometrically stable resonance cell. Think of it as a perfectly balanced 3-dimensional energy unit. Now, to modulate this foundational structure and introduce what they call coherence curvature, they introduce a dipole pair, or D. This is simply a pair consisting of 1 proton and 1 neutron.
Okay, a proton-neutron pair.
Yeah. And these dipole pairs can be added to the structure, maybe attaching to one of the faces or edges of the tetrahedron, for instance. So we're looking at discrete, coherent geometric units, not just individual, randomly interacting particles.
That makes sense. So if a tetrahedral unit is 4 nucleons, 2 protons, 2 neutrons, then helium-4, which is exactly that composition, fits perfectly into this model, doesn't it? Is that why helium-4 is so incredibly stable? Almost like nature's default setting for a nucleus.
You've hit on a crucial point, absolutely. Helium-4, with its 2 protons and 2 neutrons, is interpreted in this framework as a perfect, singular, tetrahedral coherence unit. The paper strongly emphasizes its incredible inherent stability and sees it as the fundamental architectural seed of all nuclear coherence. It's truly foundational, the very first building block in this geometric language of matter.
So rather than helium-4 just being, the second element on the traditional table, this theory positions it as the primal blueprint, the unit cell from which everything else is constructed. How does this coherence-based model for helium-4 actually work then? What makes it so special in this context of vacuum coherence and resonance?
Well, the coherence-based model for helium-4 suggests that each of the 4 nucleons is precisely located at a vertex of this tetrahedron. This specific geometric arrangement forms a unique three-dimensional closed resonance.
Okay, why is that significant?
Because this configuration fundamentally minimizes what they call surface curvature, which in turn maximizes the overall field coherence across all the nucleon pairs within the nucleus. Think of it like a perfectly balanced resonating bell that vibrates with maximum efficiency. This configuration enables something called resonance phase locking among spinor fields. Basically, it means all the constituent energy fields of the nucleons align and lock into a maximally stable, coherent, and energetically efficient state. It's not just a collection of particles. It's considered the unit cell in our resonance lattice, the most harmonious and stable fundamental arrangement.
So it offers a deeper reason for its stability than just, say, the strong force or shell model magic numbers.
Exactly. Conventionally, helium-4 stability is understood through the strong nuclear force and its magic number status in the nuclear shell model nucleons filling complete quantum shells. This new model offers a deeper, geometric, and coherence-driven explanation. It suggests the reason for the magic number is this perfect tetrahedral geometry.
That's a huge conceptual leap, suggesting a fundamental geometric order instead of just statistical arrangement. Okay, if helium-4 is this fundamental building block, this T unit, then what about carbon-12, the element absolutely essential to all known life? How does it fit into this recursive tetrahedral framework?
Here's where it gets really interesting and connects the very small to the very large. Carbon-12, the stable isotope foundational to all known life, is described in this framework as being composed of 3 interlocked tetrahedra.
3 T units.
Exactly. 3 tetrahedral units arranged in a specific trinitarian symmetry, resulting in a total of 12 nucleons, 6 protons, and 6 neutrons. And this isn't just a coincidence for the authors. This tritetrahedral structure is described as the template for coherent nuclear genesis. It suggests a fundamental geometric basis for life itself, a cosmic design principle almost.
And this isn't purely theoretical, right? The paper actually connects this very specific idea of carbon-12 structure to recent astronomical discoveries, gives it a tangible, real-world context. Tell us more about that.
That's precisely right. Recent astronomical studies have indeed uncovered something remarkable. The widespread presence of nanodiamonds, these microscopic crystals of carbon, found embedded around young stars in protoplanetary disks.
Wow. Tiny diamonds in space?
Tiny diamonds, essentially crystalline carbon, being detected in abundance within infant star systems throughout our Milky Way. For decades, astronomers were puzzled by this faint, persistent microwave glow coming from various regions, a phenomenon they called anomalous microwave emission, or AME. Powerful telescopes have now pretty much identified these nanodiamonds as the likely source of this enigmatic microwave radiation.
So we're seeing actual carbon in this highly structured diamond form out in the cosmos, specifically around young forming stars. And these nanodiamonds are thought to form in the extreme conditions of these protoplanetary disks. How does this observed cosmic phenomenon connect back to the nuclear alchemy theory and this idea of a tritetrahedral carbon-12? That sounds like a remarkable convergence.
The connection is profound, and deeply suggestive. Our nuclear alchemical chemistry framework proposes that the carbon-12 nucleus, with its 12 subparticles, forms these 3 interlocked tetrahedra, which themselves are derived from the same fundamental unit as helium.
Right.
This implies that the formation of such a highly structured nucleus, like carbon-12, could be an efficient pathway in cosmic nuclear alchemy. The existence and abundance of nanodiamonds, these incredibly stable carbon structures in these early star-forming environments, provides direct observational evidence that complex carbon-based chemistry, likely rooted in the inherent stability of the carbon-12 nucleus, is not only active but highly efficient in these cosmic nurseries. It suggests a prebiotic efficiency, potentially influencing the very composition of emerging planets and thereby seeding the foundational components for organic life throughout the universe. It points to a deep underlying efficiency to this tetrahedral organization, almost like nature's preferred way of building.
So the implications of this go far beyond just reclassifying elements, right? This framework starts to paint a picture of how the universe literally constructs matter from these fundamental geometric units. What are the key interpretive consequences in cosmic nuclear alchemy that the paper highlights?
The consequences, when you really think about them, are truly profound, stretching across cosmic scales. First, helium as a universal tetrahedral unit. This isn't just about an element. It posits the He4 nucleus as the primary universal resonance unit in all nuclear coherence structuring. Each tetrahedron is 4 subparticles, meaning 3 of them make a 12-subparticle core, hinting at a fundamental dodecahedral symmetry potential, maybe at a deeper level. It suggests a universal language. Second, the trinitarian tetrahedral structure of nuclei. This proposes that larger nuclei don't just randomly grow. Instead, they emerge from recursive or rotational bonding of these 3 tetrahedral cores, the carbon-12 template. This process actively generates specific coherent zones and field resonances for heavier nuclei through what's called geometric symmetry nesting, like building increasingly complex Lego structures by stacking and interlocking these fundamental pyramids. Third, and this is crucial for the cosmic story, is the cosmic efficiency of helium and carbon formation. If the early universe and stellar interiors naturally facilitate this tetrahedral clustering and bonding, then helium becomes the definitive gateway nucleus. This implies an incredibly efficient route for all subsequent element formation, enabling early carbon and organic synthesis pathways right from the start. It literally seeds the cosmos with coherence-rich matter, paving the way for biological emergence.
Wow.
And finally, it points to a foundational architecture of organic life. The framework argues that life-bearing molecules, which fundamentally rely on carbon's tetrahedral bonding, think methane, amino acids, sugars, aren't just chemically optimal. Instead, it suggests a direct nuclear molecular isomorphism.
Meaning
Meaning the resonant symmetry and inherent stability derived from nuclear coherence in elements like helium and carbon are directly echoed and preserved in the very biological complexity of molecules. This whole perspective is encapsulated in the TNGP, the Tetrahedral Nuclear Genesis Principle. All coherent nuclei structured through recursive tetrahedral lattices, helium the primal unit, and organic life emerging universally from this resonant architecture. It's a complete geometric story from vacuum to life.
That's incredibly elegant, suggesting a consistent geometric language from the smallest nuclear structures all the way up to complex biological systems. And the paper even offers an equation for this, right? The nuclear resonance coherence equation, trying to quantify this emergent order.
Yes, exactly. The nuclear resonance coherence equation, or NRCE, is introduced as an attempt to quantify this emergent coherence. In its general form, it's expressed as EC equals CNR TRT FN. Here, EC represents the emergent coherence energy, basically, how stable and organized the nucleus is. T is the number of coherent tetrahedral units. RT stands for resonance tier, which corresponds to the element's position on the new periodic table. And FN is a function often related to 12 subparticle systems like N12, where N is the total nucleon count, hinting again at the importance of that tritetrahedral core. What's also key here is the coherence number, Cn, defined as Cn equals 4 plus 2d. This coherence number is presented as the primary index of nuclear resonance structure. Essentially, it acts as a geometric blueprint for the nucleus's organization and a predictor of its stability. It's a way to mathematically describe this deep underlying order.
Okay, this is all incredibly compelling. It paints a very different picture of matter. But as a listener, I'm already wondering, and maybe you are too, is this coherent tetrahedral model truly real? Or is it a kind of elegant, maybe overly ambitious theoretical construction? How do we critically evaluate this? What are its potential limitations?
That's a crucial and absolutely fair question. The paper itself is actually quite transparent about this. On the side of strengths, the model has this remarkable, elegant symmetry. It harmoniously aligns helium and carbon with tetrahedral geometry, which profoundly mirrors the molecular structures foundational to organic chemistry, suggesting a deep continuity.
Right, that connection is powerful.
It is. It also boasts universal applicability. positing this coherence-based geometric pathway from simple nuclei to complex life, resonating with broader concepts in coherence physics,
Yeah.
even the idea of a conscious universe. And the efficient pathway argument is very strong. If the tetrahedral helium unit is the primal seed, it provides an incredibly efficient cosmic alchemy route for rapid matter structuring, especially for life-essential elements like carbon. The elegance and resonance of the logic, while new, feels deeply grounded in natural patterns.
All right, but what about the other side? The weaknesses.
Right. We must also acknowledge potential weaknesses in areas needing more work. The biggest challenge, honestly, is that current mainstream nuclear physics, particularly quantum chromodynamics, or QCD, while it doesn't explicitly describe nuclei in terms of geometric subparticle tetrahedra, QCD explains the strong force quark and gluon interactions within nucleons and how nucleons form nuclei. This new framework would require a significant reinterpretation, or at least a deep expansion of QCD, to integrate this geometric, coherence-based view as foundational. It's not necessarily a contradiction, but definitely a different level of description. Also, the 12 subparticles in the tritetrahedral core need more formal classification. What exactly are they? Quarks, emergent coherence units, specific symmetry nodes. And scaling this fundamental unit to heavier elements like iron or uranium, well, that needs much more elaborate structural algebra, maybe a lattice field extension, to fully describe their complexity and stability. Without direct experimental proof of these geometric substructures, it remains a powerful, compelling hypothesis.
So it's not just a neat idea, but perhaps a new generative language awaiting formal grounding, like historical leaps in physics, where new math sometimes came before full empirical proof. It's a bold hypothesis, then, one that challenges us to look deeper. And this ambitious new framework leads to what the paper calls the coherence-based periodic table of elemental genesis. That sounds, well, truly revolutionary.
It is indeed. This is arguably the first truly new periodic system proposed in over 150 years. The traditional table, while incredibly robust, largely classifies elements based on observable features like atomic number, electron configurations, which are, in a sense, surface phenomena or emergent properties. This new table, which they call the resonance lattice periodic map, is fundamentally different in its very purpose.
How so? What makes it revolutionary beyond just being new? What's the core departure from Mendeleev and the quantum models?
Okay, first and most significantly, its ontological foundation. Instead of classifying elements by electron configuration, which they describe as phenomena emerging from the nucleus, this table classifies elements by their nuclear coherence architecture. This is seen as the structural and generative cause, the deeper blueprint.
Ah, cause versus effect.
Exactly. The paper explicitly posits that electrons emerge from nuclear coherence, meaning this table is describing the cause of element behavior, not just the effect. It models why elements have their forms, not just what they are. Second, it brings in dimensional inclusion. The traditional table is largely 2D, based on atomic number and electron shells. This new system introduces nuclear geometry, resonance stability, and symmetry curvature as primary axes. Imagine a 3D or even multi-dimensional map where one axis maps symmetry distortion, another tracks the number of tetrahedral units. It introduces a form-generative logic. Third, it boasts universality across the cosmos.
Yeah.
Because it's based on these universal coherence principles and tetrahedral resonance logic, it applies far beyond just Earth chemistry. It connects directly to cosmic nuclear alchemy, stellar synthesis, even the fundamental structure of biology. It bridges pathways from early universe helium fusion all the way to complex carbon life and heavy elements. Fourth, comprehensive integration of all elements. In principle, every nucleus can be mapped, described as a specific combo of tetrahedral units, T, and coherence distortion units, D, located via the coherence number, CN4T plus 2D, and assessed for stability via a symmetry function. This allows for defining new coherence isotopic families, and even exploring hypothetical superheavy elements as coherence overextension artifacts, elements pushing the limits of geometric stability. And finally, its profound transformational applications. This framework doesn't just describe, it redefines atomic number, mass, isotopic identity. Crucially, it provides a coherence-based pathway for elemental transmutation, suggesting a new, more efficient way to change elements. This could bridge quantum physics, nuclear structure, biology, potentially guiding new energy systems, resonance-based materials, novel biological interventions. In essence, it's revolutionary because it's ontologically derived, models the why, and integrates nuclear genesis, resonance physics, and cosmic emergence into a unified whole.
That's a huge claim explaining why elements exist and stabilize, not just that they do. So how does this new table actually organize the elements? We're so used to rows and columns based on electron shells. How does periodicity, that repetition of properties, arise here?
Yeah, good question. In this new framework, periodicity arises from distinct tiers of nuclear coherence, rather than electron shells. These tiers are fundamentally defined by the number of tetrahedral units, T, and dipole additions, D a nucleus contains. Each tier corresponds to a unique coherence domain, characterized by its inherent stability, geometric configuration, and field curvature. Think of it like levels of increasing structural complexity and coherence potential.
Okay, can you walk us through that? Give us some examples.
Sure. Let's walk through the tier structure of elemental genesis table with some specific examples to make it concrete. Tier 1, 1T, features helium-4. This is absolute pure symmetry, the foundational coherence unit. Just one perfect tetrahedron, most stable, most fundamental.
The starting block.
It's exactly.
Whatever.
Tier 2, 3T, brings us to carbon-12.
Oh, yeah.
The life seed, representing highly stable triadic symmetry, 3 interlocked tetrahedra. Its prevalence in life. Not an accident here, it's a peak of nuclear coherence.
Right.
Tier 3, 3T plus 1D, introduces nitrogen-14. Here you have the 3T core from carbon-12, but add one dipole pair, one proton, one neutron. This creates a slight curved symmetry, leading to semi-stable isotopes still vital for life, but reflecting a subtle wobble in that perfect triadic symmetry.
Okay.
Tier 4, 4T, is oxygen-16, another really special case. Described as representing quadratic closure or maximum symmetry resonance, and envisioned as a perfect 4-tetrahedral cube. Hyperstable, energetically efficient like He4 and C12, a major anchor point for coherence.
So these are like the super stable points.
Precisely. Tier 5, 5-8T, includes elements like neon-20, magnesium-24, silicon-28. Here you start seeing coherence grid formation. Nuclei forming more complex yet still highly ordered geometric lattices by adding more T units. Tier 6, shell curvature, encompasses things like sulfur-32, argon-40, calcium-40. Now the added units introduce more significant shell curvature or field torsion. The initial perfect tetrahedral arrangement starts to expand, twist, leading to larger ring and spiral-like substructures.
It's getting more complex.
Yeah. Tier 7, resonance density maxima, contains crucial elements like iron-56 and zinc-64. These form incredibly dense, high-spin coherent matter, peaks of resonance density, where the structure achieves a new level of efficient packing and stability. Iron-56, especially, noted for its exceptional stability. And finally, Tier 8, coherence break zones, includes the heavier elements like bismuth-209, uranium-238, thorium-232. These are decay-prone, asymmetry-dominated regions. Configurations where the increasing complexity and number of nucleons lead to inherent field distortions that push the limits of coherent symmetry, making them naturally unstable, radioactive.
It's fascinating. Each tier adds complexity, but as you go up, you risk disrupting that symmetry, which leads to radioactivity. So these tiers aren't just descriptive, they're fundamentally predictive of stability and behavior. How is that prediction formalized? Is there a math system underpinning this geometric organization?
Yes, exactly. The coherence number, Cn equals 4T plus 2D, serves as the primary organizing principle and a key predictive metric. It's designed to predict stable or semi-stable nuclei. The tetrahedral units 4T ensure fundamental geometric resonance, while the dipole pairs 2D fine-tune mass and charge distribution, allowing for a range of stable configurations. Significant deviations from this ideal Cn or a lack of proper T and D arrangement are seen as direct indicators of instability or predictable decay. Beyond that, they introduced Tetrahedral Nuclear Algebra, or TNA. This is a more advanced mathematical framework allowing precise algebraic description of nuclear architecture and stability. Within TNA, the nuclear composition equation is Cn equals 4T plus 2D, but TNA also includes a symmetry function, F10. This quantifies the geometric symmetry. The key rule: if SN01, it indicates a coherent stable nucleus. If NC10 drops below 1, it implies a significant symmetry deficit, leading to instability. It provides a rigorous algebraic basis for this geometric view.
So elements aren't just arranged by atomic number, but they fit into this resonance lattice periodic map, where each element occupies a lattice cell defined by nucleon count and symmetry class. That's a fundamentally new way to visualize the elements. Can you give us some concrete examples from this nuclear alchemy configuration chart? How do familiar elements like carbon or oxygen look in this new light, defined by T, D, and Cn?
Certainly. Let's look at key examples from their extended coherence nuclear configuration table to illustrate this geometric logic. For helium-4, the quintessential stable isotope, super simple. One tetrahedral unit T1, 0 dipole pairs, D0, gives a coherence number, Cn of 4, most basic perfectly symmetric building block.
T1, D0.
Cn2.
Got it.
Carbon-12, foundational to life, exemplifies triadic resonance. Assign 3 tetrahedral units, T3, 0 dipole pairs, Cn12. Perfect fit for the 3 interlocked tetrahedra model. Beautifully symmetrical, stable.
T3, D0, CN12.
Okay, move to nitrogen-14, very common. 3 tetrahedral units, T3, 1 dipole pair, D1. Makes it CN14. Clear demonstration of adding a dipole pair to the fundamental 3T core, modulating coherence without major disruption.
T3, D1, CN14.
Oxygen-16, another prime example of perfect symmetry. 4 tetrahedral units, T4, 0 dipole pairs, D0, CN16. Consistent with the perfect 4 tetrahedral cube idea. Highly stable, closed geometric configuration.
T4, D0, CN16. These stable ones seem to favor D0.
Often, yes, representing maximum symmetry closure. Now look at a heavier stable element, iron 56. Modeled with 14 tetrahedral units, T14, 0 dipole pairs, D0, CN of 56. Suggests a dense, recursive packing of tetrahedra maintaining high coherence.
T14, D0, CN56. Still 0 dipoles.
Right. But now consider uranium-238, complex and unstable, though long-lived. Modeled with 59 tetrahedral units, T59, and 10 dipole pairs, D10, gives a very high CN of 256. This large number of units and dipoles signifies a highly complex, perhaps structurally strained configuration, leading to its eventual decay.
T59, D10, CN256. So the dipoles aren't inherently bad, but maybe too many or in the wrong arrangement with many tetrahedra leads to instability.
Exactly. It's about the balance and the overall geometric harmony.
That immediately reveals a powerful geometric logic behind composition and stability. But what about isotopes, the variations with different numbers of neutrons like C13 or O18? How does this framework integrate isotopes into this geometric logic?
This is where the geometric logic of isotope integration becomes really insightful. The base principle is that each stable isotope isn't just a random variation, but a precise geometric perturbation or subtle enhancement of a core coherent structure.
Okay.
These perturbations are managed mainly by 2 mechanisms: dipole additions, adding a proton-neutron pair, or isotopic curvature, which describes a slight, tolerable deformation or field asymmetry within the overall nuclear lattice. It's like adding a small, perfectly placed weight to a balanced sculpture. Shifts the balance, but doesn't topple it if it stays within tolerance. Let's use carbon and oxygen again. Carbon-12, pure symmetrical 3T unit, super stable. Carbon-13, C12 plus 1 neutron. In this model, that neutron isn't just added randomly. It's integrated, maybe fitting into a specific vertex or central field, maintaining overall coherence. It's a harmonic isotope.
Okay.
But carbon-14, C12 plus 2 neutrons, the extra neutron creates a larger distortion affecting its decay threshold, pushing it toward instability. It's a detuned isotope.
Key-tuned, I like that analogy.
Yeah. Similarly, oxygen-16, perfect 4T cube, max coherence. Oxygen-17, O16 plus 1 neutron. Oxygen-18, O16 plus 2 neutrons. Even with the added mass in O18 used in paleoclimatology, it's still considered coherent enough for stability and function. The general pattern, neutron additions deform the coherent surface or internal field. When that symmetry curvature or field distortion exceeds the threshold, decay probability jumps. Proton additions primarily increase charge curvature, which can destabilize even more unless precisely balanced by neutron mass and geometric integration.
So the interpretive rule really is nuclei grow by symmetric tetrahedral recursion or by coherence-aligned nucleon pair appending. Stability peaks when symmetry is closed. That makes a lot of sense. Stability as a geometric sweet spot, a state of perfect resonance. This brings us to a closer look at isotopic resonance and how it redefines the ancient concept of alchemical transmutation.
Indeed. In this coherence framework, isotopes are fundamentally reinterpreted, not just random mass variations.
Yeah.
Instead, they're coherence layer deviations within a nuclear resonance shell. Imagine a perfectly tuned musical instrument. An isotope is like a slightly different tuning, either subtly enhancing harmony or introducing dissonance. Each isotope represents either a perturbation of the underlying symmetry field neutron excess, proton curvature, or a precise shift in coherence potential that can stabilize or destabilize the whole nuclear lattice.
Okay.
The paper describes different types of isotopic resonance, categorizing by coherence behavior. First, harmonic isotopes like C13, O17. They maintain internal field symmetry and resonant frequency despite added nucleons. Just add mass without disrupting core harmony. Then overtoned isotopes like Mg25. Add coherence mass without fundamentally disrupting core structure. Add overtones to the existing resonance. Finally, crucially, detuned isotopes, characterized by misaligned field additions. Additional nucleons break internal symmetry, leading to unstable radionuclides like C14U235. You can visualize these as resonance wells in a topological landscape of coherence, like a contour map. Stable isotopes lie deep in valleys of max coherence, metastable ones on gentle ridges, radioactive ones precariously on cliffs, easily decaying into more stable states.
Thinking about it as a resonance landscape with valleys and cliffs makes stability and instability much more intuitive, dynamic. And if isotopes are about rebalancing these coherence fields, then the ancient idea of alchemy, changing one element into another, that takes on a profound new scientific meaning, doesn't it? What are these alchemical transmutation pathways? How does this new alchemy work?
This is where alchemy truly gets a scientific rebirth, yeah. Moving far beyond medieval superstition. Transmutation, in this view, fundamentally doesn't happen by brute force collision, like smashing particles in a collider. Instead, it occurs by subtly adding or removing energy, or, more accurately, by precisely modulating the coherence from the nucleus.
Modulating coherence.
Exactly. This modulation rebalances internal field curvature, leading to a profound reconfiguration of the underlying tetrahedral or dipole subunits. It's like gently tuning a complex geometric puzzle until it clicks into a new, stable configuration. Much more elegant. The paper introduces a general alchemical pathway equation where one element transitions to another via a coherence modulation operator. For example, the well-known beta decay of carbon-14 to nitrogen-14, a neutron, becomes a proton, emits an electron is explained not just as particle decay, but as a specific neutron decay, with an associated dipole reconfiguration rebalancing nuclear coherence. Similarly, fundamental stellar fusion, like He3 plus He4 forming B7 in the Sun, is understood as precise, multi-step tetrahedral fusions, where geometric units combine in an energetically favorable, coherent way. Even uranium-238 decay to thorium-234 is seen as asymmetry shedding via alpha emission, which is basically a He4 nucleus tetrahedron, where the complex structure releases a coherent unit to achieve a more stable state, all following field geometry rebalancing rules, not just raw energetics.
That's fascinating. It shifts transmutation from high-energy brute force to something potentially much more subtle, controlled. Aligns with what some controversial models of low-energy nuclear reactions, LNR, have hinted at for decades.
So are we talking about artificial transmutation in coherence reactors?
Yeah.
A new form of energy.
Yeah.
Exactly. Coherence-based transmutation, in this framework, proposes low-energy conversion. The idea is, instead of massive energetic bombardments, transformations could be achieved by precisely modulating local coherence fields around nuclei. By carefully tuning these fields, you could induce nucleon alignment into new geometric states, facilitating symmetry-based reformation, not brute force.
Wow.
This aligns remarkably well with LNR cold fusion models, even some biological transmutation hypotheses, where life itself might subtly transmute elements at low energy. It opens the possibility of future quantum alchemical coherence chambers, performing precise elemental conversions for energy, waste remediation, generating rare materials, all through manipulating underlying geometric coherence.
And this naturally leads to perhaps one of the most radical ideas, life and isotopic selection. You mentioned life prefers certain isotopes. What's the deep coherence explanation, and how does it challenge conventional biology?
This is truly profound, one of the most compelling connections. The paper presents the radical idea that life prefers specific isotopes, C12 over C13, O16 over O18, H1 over deuterium, H2, not just for bulk chemical properties or abundance, but critically for their field stability and resonance compatibility.
Resonance compatibility.
Yes, suggesting biology is inherently sensitive to nuclear coherence. Living systems are finely tuned to the subtle energetic harmonics of the nuclei themselves. It's not a chemical accident these isotopes are ubiquitous. It's a profound, field-driven preference. They illustrate this with a biophase resonance alignment of key biological isotopes chart. It visually shows isotopes like H1, C12, O16, and 14 exhibit near-perfect coherence alignment within biological systems, explains their universal biological ubiquity and energetic efficiency. Even more telling is the resonance alignment shift from isotopic substitution. Shows how minor isotopic changes, C13 for C12, N15 for N14, can significantly reduce biological resonance alignment. The paper points out even small coherence deviations, a delta value of just 0.0700.8, a tiny shift in resonant frequency or field harmony can push a nucleus's coherence below biological thresholds, leading to subtle yet critical phase inefficiency, altered enzyme function, compromised signal fidelity within complex biological systems.
So it's not just that life uses these isotopes, it actively selects them because they're in precise resonance with the very field dynamics of life. Preferences aren't chemical accidents, but deep, field-driven selectivity. Life uses resonance valleys as coherence anchors.
Wow. This suggests a much deeper connection between biology and the underlying geometric structure of matter than we've ever considered.
Yeah.
And the sensitivity to subtle field dynamics leads into even deeper geometries and unifying fields, right? Indeed. To truly grasp the underlying mechanics, we need more advanced math concepts, particularly from geometric algebra. The paper introduces bivectors as fundamental. In geometric algebra, a bivector is essentially an oriented plane segment, or, more intuitively, a rotation plane.
Okay.
They're not just abstract math, they model fundamental physics like quantum spin, electromagnetic fields, inherently describing directed areas, not just points or lines. A bivector is formed by the exterior product of two vectors, representing an area with intrinsic orientation. Now, here's the revolutionary idea. A tetrahedron is proposed as a 3-bivector coherence shell. Each face corresponds to a fundamental bivectorial field plane. Their collective closure geometric and energetic alignment yields a specific resonance manifold. This is significant because it implies spin is not imposed. It emerges via tetrahedral coherence collapse. The tetrahedron itself, this fundamental block, inherently encodes quantum spin because of its intrinsic bivectorial nature and how its field planes align and close. The paper even mentions a tribivector matrix suggested to encode spin and symmetry closure within the tetrahedron structure. It's saying geometry isn't just a container for physics, but a source of physical properties.
That's mind-bending. Spin, usually just described, actually arising from this deeper geometry. And this geometric algebra also ties into Finsler coherence phase integration. What's that?
Right. Finsler geometry is a powerful generalization of Riemannian geometry, which Einstein used for space-time. In Finsler geometry, the metric how distances and curvatures are measured depends not just on position, but also direction of motion. It inherently understands directionality. When coherence is integrated, the direction-dependent Finsler geometry allows tetrahedral bivector fields to define curvature-localized directions, meaning the inherent coherence, curvature, and phase relationships of these tetrahedral units aren't separate properties, but integrated into a single, unified geometric description. The tetrahedron isn't just a nuclear structure, it's a coherence geometric operator in this Finsler phase space, actively defining localized directions and curvatures within spacetime based on its bivector fields, a dynamic interplay between geometry and vacuum.
Sounds like a profound step toward a unified field theory, weaving geometry, quantum mechanics, vacuum into one fabric. And speaking of unifying geometries, this framework immediately brings Buckminster Fuller to mind.
Absolutely. Fuller's synergetics is incredibly resonant here. Fuller proposed the tetrahedron as the minimal system in 3D space, asserting all vectors within it are in fundamental tension, creating an inherently balanced, stable structure. From this minimal unit, he showed how nature recursively builds to other fundamental shapes like octahedra, icosahedra, dodecahedra, suggesting geometry as nature's fundamental language of coherence and efficiency, not just abstract description. He saw them as fundamental energy flow patterns.
How does Fuller's synergetics, especially those larger shapes, apply directly to nuclear alchemy specifics? What roles do these higher-order geometric forms play?
In our coherence framework, these secondary higher-order structures from Fuller take on meaningful roles as specific coherence configurations, representing different energy states or structural arrangements within nuclei. For instance, the octahedron, formed from two dual tetrahedra joined at bases, could be a coherence antinode structure. Might model isotopic inversion or resonance nodes where coherence fields invert, like in certain isotopes, maybe O18, where added nucleons create a balanced yet distinct geometric state. The icosahedron, with 20 triangular faces, 12 vertices, is seen as high coherence shell closure, representing extremely dense packing coherent zones, like in exceptionally stable heavy elements like iron 56, highest binding energy per nucleon, also aligns with the high symmetry of noble gases, which could have closed, like icosahedral-like coherent shells. And the dodecahedron, 12 pentagonal faces, 20 vertices, could act as a vacuum curvature interface. Powerful for modeling resonant fields, scalar resonance shapes, even coherence decay zones, like in heavy, unstable elements like U-238. These geometries aren't arbitrary. They represent a hierarchy of nested coherent structures, different field shells in vacuum phase space, even thresholds of nuclear phase transitions where elements gain or lose stability based on maintaining these ideal forms.
So not just abstract forms, they're the language nature uses to design matter, small to large scale. And on unifying geometries, Nassim Haramein's work also comes up, his 64 tetrahedron grid. Does that fit in maybe as a deeper background field?
It absolutely does, quite elegantly. Harameин's 64 tetrahedron grid, 64 interlocked tetrahedra, and a balanced vector equilibrium structure can integrate as a profound conceptual underpinning. It could potentially represent the pre-nuclear vacuum coherence field itself, the underlying energetic lattice from which nuclear coherence units emerge. If our fundamental T unit is a tetrahedron, then 64, which is 4 cubed, 4 by 4 by 4, signifies a third-order nesting, pointing to a fractal vacuum nature. This grid could also map onto dense coherence zones, perhaps explaining F56's exceptional stability and density, where nuclear structure approaches this integrated grid. Furthermore, the grid's overall symmetry and force balancing could be a geometric analog of a gauge group in physics. Specific deformations or broken symmetries within this lattice yield curvature and coherence gradients, giving rise to matter and properties, much like gauge bosons emerge from broken symmetry in quantum field theory.
Powerful. These geometric configurations, far from abstract, may actually serve as discrete phase space operators of the vacuum. Not just descriptive, fundamentally generative of reality shaping existence. And if coherence governs matter so profoundly, could it also govern life itself beyond conventional biochemistry and genetics? This coherence bioenergetics sounds like a complete paradigm shift for biology.
That's the logical and, I believe, inevitable extension, yes. Coherence bioenergetics proposes a radical new understanding. Biological energy flow isn't merely biochemical reactions, but fundamentally governed by resonance alignment, coherent shells, and isotopic field fidelity. It's a framework positing all life processes emerge from phase-lock resonance within highly structured coherence matrices, extending from atomic nuclei right up through intricate cellular lattices. Life, in this view, is a grand symphony of coherence.
Okay, what are the core principles?
The fundamental principles are quite specific. First, coherence gradient dynamics. Life optimizes energy flow not just along chemical gradients, but along field-aligned vectors of least resistance. Processes like ATP production, ion channels, redox pathways actively follow spatial and scalar coherence attractors, finding most efficient paths. Second, isotopic field resonance. We touched on this, critical here. Biological systems actively select isotopes like H1, C12, O16 because these nuclei maximize vibrational symmetry and maintain optimal resonance within the biological field. Deviations, even minor ones like a C13 atom and a critical enzyme, alter signal fidelity, disrupt energy transfer, compromise function because they've detuned the system.
Right, the detuning.
And finally, scalar shell coupling. Bioenergetic systems operate in nested scalar shells, similar to atomic orbitals but based on field interactions. Think mitochondrial fields, DNA coherence channels, fields around organs, all resonating in harmonic tiers, exchanging energy through phase alignment.
Can you give more concrete examples at a cellular level, connecting these principles to the actual machinery of life?
Certainly. At the cellular level, this offers fascinating reinterpretations. Mitochondria, the powerhouses, seen not just as chemical factories, but phase-driven coherence processors, designed to receive and transform energy not just from glucose, but surrounding coherence fields. ATP synthase, that amazing molecular machine producing ATP, re-envisioned as a quantum rotational coherence rotor. Its spinning mechanism isn't just mechanical, but actively synchronizes quantum phase, efficiently converting field energy into biochemical energy. Even microtubules, the cell's cytoskeleton and highway system, propose to sustain coherence tubes, thought to facilitate incredibly rapid, efficient energy flow, maintain cellular memory, even modulate spin states. Crucial for cellular communication may be consciousness. Our entire bioelectric lattice, the body's electrical signals, thought to encode potential phase alignments between cell clusters, organs, orchestrating collective behavior.
Wow.
To quantify this, they introduce a resonance efficiency equation. CRA. EB is bioenergetic potential vitality. CR is coherence ratio, resonance alignment. EBS is isotopic stability index, fidelity of isotopes used, and is phase locking efficiency, synchronization of fields. Suggests bioenergetic potential peaks in systems perfectly tuned to isotope-aligned resonance shells, operating with max coherence, minimal energy loss.
So a truly revolutionary way of looking at biological energy beyond pure chemistry. The implications for application medicine, healing, human potential are immense, aren't they?
Enormous. This opens entirely new avenues in regeneration, enhancing coherent shells and stem cell activation, guiding growth more precisely. For healing, rephasing disrupted cellular fields to correct decoherence damage, underlying many diseases, potentially faster recovery. for optimizing performance, maximizing bioenergetic potential via field-aligned nutrition, light therapies, breathing techniques enhancing internal coherence. In diagnostics, mapping coherence ratio gradients to detect disease or dysfunction at a fundamental energetic level before macroscopic symptoms. Energy radically redefined, not just quantity calories, but a profound quality of organized resonance, suggests a universe and life unfolding not from random chance or entropy, but from the very harmonics of coherence, a beautiful, ordered progression.
That's a profound redefinition of life, seeing it as an extension of these fundamental patterns. And all of this entire framework is built upon a single foundational principle, right? The grand statement tying it all together.
Yes. The foundational principle of nuclear coherence structuring is the overarching axiom. It states, all stable elemental forms arise from the recursive modulation of tetrahedral coherence units through symmetry-aligned field resonance within the vacuum coherence matrix. Okay. This is the core statement, what it implies. Mass, charge, isotopic behavior aren't arbitrary properties. They're mere expressions of geometric alignment or deviation from this fundamental coherent foundation. Nuclei aren't chaotic bags of quarks or probabilistic clouds, but inherently field harmonic resonators, dynamic geometric structures constantly resonating with the vacuum. Stability emerges directly from geometric coherence, not just nucleon count. Flips the script on how we perceive matter.
And from this principle, the paper derives the 12 coherence laws of elemental genesis, like a new set of commandments for understanding the universe. Let's walk through a few, maybe focusing on the ones that fundamentally reframe our understanding.
Absolutely. These 12 laws summarize the operating principles. Let's highlight some impactful ones. 1. Tetrahedral primacy, most fundamental. All nuclear matter is composed of discrete or nested tetrahedral nucleon units. What's the biggest takeaway for you from that first law?
For me, it's that matter isn't just arbitrary particles. There's a fundamental, perfect geometric shape at its core. A universal blueprint makes the abstract nucleus feel more ordered, designed.
Good point. 2. Triadic resonance. Tritetrahedral structures like carbon-12 represent the first complete resonance node, forming the basis of organic life. Crucial. Links nuclear geometry directly to life's emergence. Implies carbon suitability isn't chemical accident, but consequence of perfect triadic coherence. Universe is a sweet spot for complexity.
Makes sense. 3. Symmetry closure. Stability arises when tetrahedral units complete geometric closure, forming minimum curvature surfaces like oxygen-16.
Yeah.
So stability is literally achieving a perfect geometric form, a closed, harmonious shape. Like a puzzle piece clicking perfectly into place, becoming unshakable, speaks to the elegance.
Exactly. 4. Coherence number, we discussed. CNs equals 4T plus 2D governs nuclear stability. Deviations require compensatory symmetry or lead to decay, the mathematical backbone. 5. Dipolar modulation. Dipole nucleon pairs can stabilize or destabilize based on field curvature alignment, the fine-tuners. 6. Resonance tiers. Elements fall into discrete resonance tiers, each with unique symmetry, curvature, mass, energy properties. Explains the new table structure. 7. Isotopic curvature. Isotopes are coherent field deformations, tolerable only within specific resonance curvature thresholds. Helps understand isotope stability. 8. Transmutational reversibility. Bold claim. All nuclear states are in principle reversible via geometric or energetic coherence modulation, the core of new alchemy.
That's a game changer. It means transmutation isn't rare, violent, but potentially controllable realignment of fields like tuning a radio. If true, implications for energy resources are staggering.
Huge potential. 9. Vacuum alignment. Vacuum field provides coherence scaffolding. Structures arise where tetrahedral fields align with vacuum coherence nodes. Links matter directly to empty space. 10. Coherence energy efficiency. Energy released absorbed proportional to symmetry reformation, not merely mass difference, favoring low-energy resonance transitions. Why Leninar is possible here. 11. Biogenic preference. Living systems prefer isotopes and elements with maximum internal resonance symmetry, C12O16H1. The biology connection.
So life isn't just using what's abundant. It actively seeks elements resonating most harmoniously with its own coherent structure. Biology as a deeply selective process rooted in physics.
Precisely. 12. Universal continuity. Finally, elemental coherence follows a cosmic continuity, connecting nuclear structuring with molecular bonding, biological form, planetary organization.
Truly a unified theory, transcends conventional physics, touches philosophy, suggests a profound new path for civilization. What are the broader philosophical implications? How does it change our understanding of reality?
The most profound philosophical shift. Matter is not random, it is rhythmic. The paper argues, fundamentally, nature does not build by force, it builds by form. This table doesn't just describe particles, it explains why they exist stably. Suggests the nucleus isn't chaotic bag of quarks, but resonance engine, geometry of intent, symmetry of relation. Where mainstream physics sees stochastic processes, this framework sees underlying order, purposeful emergence from fundamental geometric principles. Implies a universe of inherent pattern design.
And this gives profound new life to alchemy, right? Alchemy reborn, not medieval superstition, but rigorous geometry of coherence transformation.
Exactly. Alchemy recast as understanding matter is transformable through precise field alignment and resonance. The legendary philosopher's stone isn't a substance but a process. Perfect alignment with the underlying symmetry of creation. Nuclear alchemy becomes not just theoretically possible, but perhaps inevitable in an advanced coherent civilization, mastering these field dynamics. Changing matter is about tuning its song, not smashing it. This also deeply touches consciousness and elemental symmetry. If coherence governs matter, and consciousness interacts with coherence, the paper provocatively suggests consciousness is not outside this table, it may be its highest reading. Carbon and oxygen stability in life isn't incidental, it's profound resonance alignment between element coherence and life's organizing principles. Life is a geometric extension of the elements. The same symmetry stabilizing he and O echoes in DNA's helix, complex cognitive fields, maybe even collective civilization structures. Profound unity.
So this implies a path toward a coherent civilization, one not extracting and burning, but reconfiguring and tuning matter, operating in harmony. A culture grounded in harmonic alignment where science, philosophy, spirituality converge, understanding reality is structured by inherent beauty, symmetry. And the paper even adds an epilogue about S3 symmetry, bringing it back to fundamental physics.
Yes, the epilogue addendum brings in S3 triadic symmetry, a mathematical permutation group of 3 elements. Profound in physics, governs color charging QCD. In this framework, S3 acts as a resonant operator, fundamentally giving rise to the 3 interlocked tetrahedral coherence fields, like in C12. This implies nuclear coherence is the geometric echo of primordial field permutation, a song of symmetry descending into form. In this radical view, chromodynamics isn't just quarks interacting, it's a fundamental phase of coherence expression, leading from vacuum field symmetry to stable matter, complex molecules, ultimately mind, consciousness, an all-encompassing dance of symmetry.
We've journeyed from an atom's core to reality's fabric, seeing how a revolutionary understanding of elemental genesis, rooted in geometry and coherence, might rewrite textbooks and our understanding of existence. This periodic table of elemental genesis isn't just a static chart. It's truly a mirror of emergence, a symphony of tetrahedra, a bridge between form and field. So this leaves us with a provocative thought. If everything is fundamentally organized by coherence, what else in the universe follows these rhythms? What hidden forms and patterns remain undiscovered, not because they don't exist, but because we haven't yet learned to listen to their symmetry, to perceive their coherent song? Ultimately, the profound idea here is that to transmute matter is to understand it. To understand it is to resonate with it. To resonate is to become it. And in becoming it, we remember that we are not separate from the cosmos. We are its coherent expression. Thank you for joining us on this deep dive.